Lean in closer. What do you hear? In a perfectly soundproofed room, you wouldn't hear silence. You'd hear the rush of blood in your ears, the thumping of your own heart. We are creatures of sound, so the absolute silence of space feels alien, even terrifying. For centuries, we've called it the Great Silence. A perfect, unending vacuum where no scream can travel, no whisper can survive. But what if that's all wrong? What if the void isn't silent at all? What if, beneath the quiet, the universe has been humming a deep, resonant bass note since the dawn of time? A vibration not of air, but of reality itself. A forbidden song, composed by the collision of giants and sung across billions of light years. We thought space was a silent movie, but it turns out we just forgot to plug in the speakers. And the soundtrack we've just discovered is changing everything we thought we knew about the cosmos. This isn't the kind of sound you can hear with your ears. It's not a pressure wave moving through a medium, because in the near-perfect vacuum of space, there is no medium. No, this is something far more fundamental. This is the sound of spacetime itself being stirred. Imagine the universe not as an empty stage, but as the surface of a vast, cosmic ocean. For most of human history, we've only been able to see the light glinting off the surface. But now, we've built instruments that can feel the waves themselves. Not the small, fast splashes from a rock thrown in, but the deep, long, ocean-spanning swells that travel for eons. These swells are gravitational waves, ripples in the very fabric of reality, predicted by Einstein over a century ago. For years, observatories like LIGO have detected the short, violent chirps of gravitational waves from colliding black holes and neutron stars. Those are the dramatic crescendos. But this hum, this is different. This is the background noise. It's a constant, low-frequency chorus coming from all directions at once. It's the gravitational wave background, the collective murmur of the most powerful events in the universe, all layered on top of each other. So, who are the singers in this cosmic choir? The evidence points to something almost incomprehensibly massive: supermassive black hole binaries. Picture this. Two galaxies, each with millions of stars, begin a slow, gravitational dance that lasts for hundreds of millions of years. They merge, swirling into one another. At the heart of each of those galaxies sits a monster, a supermassive black hole, millions or even billions of times the mass of our sun. As their host galaxies combine, these two titans are drawn inexorably toward each other. They begin a final, slow spiral, orbiting one another in a deadly embrace that can last for millions of years. As these two behemoths, objects with gravity so intense not even light can escape, churn through spacetime, they radiate these immense, long-wavelength gravitational waves. They are stirring the cosmic ocean. And this isn't just one pair. It's the combined hum of hundreds of thousands, perhaps millions, of these pairs all across the observable universe, all at different stages of their cosmic waltz. That is the forbidden hum we are finally hearing. But how on earth do you detect a wave that can be light years long from crest to crest and causes a distortion so subtle it's almost non-existent? You don't build a detector on Earth. You use the entire galaxy as one. An international team of scientists working on projects like nanograv did just that. They turned their attention to pulsars. Pulsars are a type of neutron star, the superdense remnants of massive stars, and they are nature's most precise clocks. They spin hundreds of times a second, sweeping beams of radio, waves through space like a lighthouse. From our perspective on Earth, we see these beams as incredibly regular pulses of energy. So regular, in fact, they rival atomic clocks for precision. The scientists created a pulsar timing array, monitoring dozens of these cosmic clocks scattered across our corner of the Milky Way. The idea was simple, but the execution was monumental. If a long, slow gravitational wave from a distant supermassive black hole binary is passing through our galaxy, it will gently stretch and squeeze the space between Earth and one of those pulsars. This distortion would cause the pulsar's radio signal to arrive a few nanoseconds later, or a few nanoseconds earlier, than expected. After more than 15 years of painstakingly collecting data, watching for these infinitesimal shifts in arrival times across all the pulsars, a pattern emerged. A correlated hum. It wasn't random noise. The pulsars were all shifting in a way that could only be explained by the subtle, constant churning of spacetime by gravitational waves. We had heard the song. This discovery is more than just a confirmation of a theory. It's the birth of a whole new kind of astronomy. It's a new sense with which to perceive the universe. This hum is the soundtrack of galactic evolution. It carries the secrets of how galaxies merge, how the largest structures in the cosmos grow, and how these supermassive black holes at their hearts become so incomprehensibly large. We are no longer just looking at the universe. We are listening to its very heartbeat. We've finally heard the background music of the cosmos, but what other forbidden notes are still waiting to be played in the silence of the void?